Hello and welcome back, guys, once again to the next video of FRAZ DSA seat, where we are solving dynamic programming level 1 problems. We have completed linear DB section completely, and we started with the two-dimensional DB, in which we have already discussed three problems. First three problems, the idea is pretty similar for all the problems, but still we will try to cover as maximum problem as possible. So today I am going to discuss the fourth problem, which is triangle. So let's see the statement, what the problem says. So given a triangle array, return the minimum path sum top to bottom. For each step, you may move to an adjacent number of rows below. More formally, if you are on index I on the current row, you may move to either index I or index I plus 1 on the next row. So the statement is quite simple and straightforward. So we'll see how we will approach this. So let me first see what are the test cases and let me explain it to you. Okay, now so let me share my board, then we will discuss how to solve this problem. So here it is saying that if you are at this current, so let me first draw the matrix. So though it looks like it is in it is given in a vector of vector form, something like this. So in the first vector you have one element, in the second vector you have two element, so in third vector you have three elements. So the input is giving like this, but just ignore this input, just try to see this matrix how it looks like. So here it's something like this, in the second row looks like this, 6 5 7 and 4 1 8 3. Okay, now we know that from any cell. So if we are at this cell, so if we are at this cell, okay, so I can either go to this cell or this cell, means I can only go to I and I plus 1 index and then next row. So if you are at this cell, you can either go to this cell and either this cell. If you are at this cell, you can go to just next cell in the next row and one more to the next row. So you can only go to this cell. So in these types of problem, we can directly apply dynamic programming techniques. These are the straightforward dynamic programming problems. But before that, just intuitively see what is the output. So let me just first remove where is the so first clear this. Why this is okay. Okay, now it is working. Okay, so 3, it's a 3. Now just see, if you have just these two, let's say you started from these two, so you have current answer as 2 because you have to take it anyway. But here from 2 you can go to 3 or you can go to 4, but which is the best option? Because you have to minimize. So if you go to 4 or if you go to 3, so here you cannot greedily pick. The reason is why, let's say just see this test case and I will show you one more test case. So let's say you go greedily. So here out of this 3 4, 3 is minimum. So here till second row your answer is 5. Okay, now if you are at 3, from 3 you go to 6 or you go to 5. So which is the best option? 5, because 5 is minimum. So you will go to 5 and 5 more. Now your answer will be 10. From this 5 you have this option and this option. So this is like 1, so you will choose going to the 1. So in this case answer would be 11. So this is one case, but why greedy will not work here? The greedy is working because the test case is generated like this. Let's say just let me give you one more test case and just try to think, if you go greedily what will happen. So something like that only, 2 3 4. Now 1 say 6 2, and from this it's a 1, and 8 7 7. So let's say you started with 2, but if you greedily pick, you will go to this 3. But if you pick this 3, you cannot you either choose this 2 or this 6. So if you choose this 2, you have to choose this 7 or this 7. So in this case the answer will be 2 plus 3 plus 2 plus 7. 7 plus 2 9 plus 3 12 plus 10 14. But there is one more possibility which is giving you minimum. So you can from this 2 you can go to this 4, from this 4 you can go to this 1, from this one you can go to this one. In this case the answer will be 2 plus 4 plus 1 plus 1, which is 4 plus 2 6 8. 8 is the minimum answer in this case. So you cannot just greedily pick at each level. You have to generate all possibilities for each cell, from where you can come to that cell, and what will be the minimum answer. So in that cases, when these things come into picture, like you have to try out all possibility. So in that case you have to try go for the all possibility. So here we will go with the dynamic programming approach to solve this problem. So for solving any problem with the dynamic programming approach, we are always using our 3-step formula. So now let's use our special 3-step DP formula. So the first step is define your DP state. So here we will define our DP state. Let's assume the input is a given matrix. So we have some cells. So we are at some I row and jth column. So if we are at ith row and jth column, so we will define our DP state is minimum sum till ith cell and jth column. So it's just a simple what is the minimum sum till ith cell and jth column. So this is our DP of ij. Now what we are always saying, that the second step would be solving for smaller cases. Now what are the smaller cases? When we have the matrix of 1 by 1, so something like that. If we have just this thing, so in that case, so this itself is, so DP of ij means DP of 0 and 0 will be 2 only. Now when we have this 1 cross 1, something like that. Now try to go further. Now something like this, it will look like this. So 3 4. So for this, and this is also 1, this is input and this is our DP state. So initially it is infinite. Here we have computed the answer to. Now for this cell, so we know that the current value of this cell is 3, and from this 3 to this 3, from where we can come to this 3. So we have only one option here. So you can only come from the top. So here what will be the answer? Here the answer will be 2 plus 3, and infinite में जो भी minimum होगा whatever. So here this is your DP, this is your input. So the answer will be, in this case the answer will be not infinite, the answer will be 5. Now let's go to this cell. Now let's go to this cell. So for 4 from to this cell, from which cell we can come? So we know that I can, the transitions are like something like this. So either down, either this. So if you just see in the reverse manner, so to this cell I can come from either above or just diagonal cell. So in this case, this to this 4 I can come from this 2. So in this case, here it will be 2 plus 4 and infinite minimum. So in this case the minimum will be 6. Now let's go one step more. We have this 2, this 3, this 4 and 2 6 1. 2 6 1. So this is our matrix. Let me draw it in a matrix fashion only, and this is our dp. So dp, and this is our input. So in dp we know that we have answer for this. This is best answer, best minimum answer. There is no other answer for this. Now these two, let's compute for these two. We are at this ij, and let's say 0 1 2 0 1 2 0 1 2. So we are computing for a dp of 2 and 0. So from dp of 2 0, from where we can come? So we can come from either this or some this. So there is no diagonal element present for this element, so we can come from top. So 2 3. So dp of 2 will be, what is the best answer till here? So best answer till here is dp of 1 comma 0 plus what is the current value? 2. So it will be, and initially it will be infinite, so minimum of this. So what will be the answer? 5 plus 2, which is 7. So here the answer will be 7, right? Now let's try to compute dp of 2 comma 1. Now this is interesting, and just by looking at this example you will be able to derive your dp transition states. So from to this cell number 6, you can come from here and also here, because you know that from these 3 you can go here and here. So to this 6 you can come from this 3 also, and from this 4 you can go down, means 6 you can come from this 4. So for 6 you have two options. So dp of 2 1 will be, you can either come from dp of 1 0 plus this 6, or dp of 1 1 and plus 6, or this infinite. So in this case your answer will be either 5 plus 6, or it will be 4 plus 6, or infinite. So out of these 3 options, 4 plus 6 is minimum. So we will store 10 here. So 10 is the best answer here. Now for similarly dp of 2 comma it's a 2, dp of 2 comma 2. Similarly dp of 2, here you can either come from this cell or this cell, right? Because from 4 you can go to 1, and from whatever the element, if there will be some element, you can come from here also. So for dp of 2 2, we have only one option here because there is no element in that cell. So dp of 1 comma 1 plus the current value and infinite, whatever is the minimum, and minimum will be the answer. So in this case the minimum will be 6 plus 1, 7. So 7 will be the answer. Okay, so out of all possibilities in the last row, for reaching last row, so in the first cell of this last row, you need 7, you have minimum somewhere 7, second cell 10, third cell 7. So out of all this, 7 is the minimum. So overall answer will be 7 in this case. So this is how you will solve. So that your transition state will something look like. So your dp of I of j will be equals to minimum of dp of I minus 1 j minus 1 comma dp of I minus 1 j current cell, and out of this whichever is minimum you will choose plus the current current means you can say here uh, nums of whatever the nums of I and j, or out of this infinity whatever will be the minimum you will store for all states, and you will just return the minimum sum in the last row of your dp table. So this is the overall solution of this problem. This is the way you will solve this. And if you talk about the time complexity, so we are iterating over this matrix, so the time complexity will be n cross m. If n is the length and m is the means n is the number of rows and m is the number of columns, in worst case it will be n cross m. And if you talk about the space complexity, it will be also order of n cross m. So this is the overall the idea of this problem. Let's try to code it quickly, and let's try to code it. Now we have vector of vector and triangle. So the vector is not given in the form of matrix. So but what we know that at the worst case your size of the vector means your size of the dp will something look like. So let's first derive n is triangle dot size. This is triangle dot size. This is your let me write, this is your, and in worst case m will be also this only. Okay, now I will quickly create my dp array, dp of n cross m, and I will mem set it to let's say dp 0x3f. It is some large value in byte format, binary format, and size of dp. Right, now we have initialized our dp with the maximum values. Now we will start traversing our tri triangle. So triangle dot size I plus plus. Now for int j equals to 0, j is less than triangle of I dot size j plus plus. So we have defined our ij loop, and we know that dp of 0 comma 0 will be triangle of 0 comma 0, which is always present, right? Because the length of the triangle will start from 1. So we do not need to iterate the row from 0, it will start from 1. Now we know that, so dp of ij we want to fill. So we know that dp of ij will be first of all dp of ij will be dp of I minus 1, which is always available because we are starting from I equals to 1, and j plus the nums of nums of triangle of ij. So this is one possibility. This is, we have to take minimum. Either this is one case, either one more possibility, dp of I minus 1 and j minus 1. So we can make it common, this I minus 1 j minus 1, or this 0x3f, and which is infinity. It's better, I can write 1 in 9, something like that. And I will add triangle of I comma j at the whatever the minimum over this. But there is one case, because here you are using j minus 1, so you have to also check. So let me write it, j minus 1 greater than equals to 0. In this case, use this, or otherwise use this. So means ki if this value is available, so if this value is available, so whatever the value that is present in dp of I minus 1 j minus 1, use that. If that is not available, then in that case use some larger value, because we have to minimize the sum. So that's why I have written this case. So we know that we got our dp of ij. So what we will do, the answer will be, so just return mean element. So whatever the mean answer that is present, means in mean element in the last row, triangle of n minus 1 dot begin, and triangle of n minus 1 dot end. So this is the overall solution of this video. Let's try to run it. So it should pass. Something missed. So yeah, that is not, definitely not the case. K, where is this is not K, this is J. Let's run it now. It should pass. Something we missed. In writing shortcuts we missed a lot of things. So it is basically, this is 3 values, so it will be in set format. That's why it is giving something missed. No matching mean. No matching function mean. Why this is giving? We cannot compute so many things in mean, minimum. So anything else? There is no matching minimum. Okay, what we missed? Something we missed with that. If j minus 1 greater than equals to 0, then consider dp of I minus 1 j minus 1, otherwise consider 1 in 9, 1 in 9. I think we cannot use in this format, so for that we have to use same data type, because mean max uses same data type. Output is 1, why it is 1? Expected is 11, coming 1. Why? Something we missed. So we are adding this triangle iz, and we are also storing. So what we missed? What we missed? Yeah, so it is possible that J is not available. Yeah, it is possible that J is like we have solved our problem on whiteboard in matrix form, but this input is not in matrix form. So let's say for 4, so for 4 the diagonal element is present, but the above element is not present. In that case it is it is getting some wrong values. So it is not possible that it always this j is available. So so for that we have to also check if a triangle triangle I minus 1 dot size is, so let's say you are at j size, you are at j2. So if this 2 is less than, if is this 2 means this 2 is means this j is less than triangle of I minus 1 dot size, in that case we will take this dp, otherwise you will take some large values and also its int. So not if is not required, just one thing is required. So this is the case. So let's try to see if j is less than why this is out, why this output is 1. Okay, this is not triangle, it's a dp. Answer is stored in dp. Yeah. Now what we missed, dpn minus 1. Okay, so we have declared in the array format, so we cannot use the functions for yeah, definitely we can use, but here what we will do, int the answer will be declared as some large value. Now what I will do, I will just traverse last row which is n I plus plus, because we know that in last row the total number of element will be n only, and the answer will be minimum of answer and dp of n minus 1 and I, and we will return the answer. So this is the answer. So yeah, it is giving as a correct answer. Now let's try to submit it. So yeah, it got accepted. So yeah, here this is little bit complicated because if you write in a separate lines it will definitely be easy. So I just try to write in a single line. That's why it looks like it is complicated, but it's not complicated at all. What we are doing, we are just taking the the value which is just above the current cell, if it is present, if it is there in the vector, or we are taking the diagonal element if it is present in the vector. If it is not present, then we are taking some maximum value so that it cannot affect our other possibilities. That's why we wrote it like that, right? Okay, so I think this is the overall idea of the solution, overall solution of this problem also. And yeah, if you like this video, definitely press like button. If you have any query, write it in the comment box. I will try to resolve it. And yeah, see you in the next video. Till then, keep learning, keep coding. Bye bye.